Hello everybody, and welcome to the beginning of section 2.5. We're looking at page 66 of the workbook, and in this section we'll be talking about the change of coordinate matrix. I think the best way to kind of get a feel for what we're going to do in this section is to start with an example. So let's read through the first part of this together. So they'd like us to consider the following two bases for R2. First, we've got beta, which is just the standard basis, and beta prime, consisting of the vectors 1, -1, and 1, 1. Okay, and what we'd like to do is to complete the table below, okay, which is going to ask us to find some coordinate vectors of points and then to plot the points on the beta and beta prime coordinate axes. Now let's say a word about what these two axes are. Okay, so to the left, we've just got the standard coordinate axes x, y that you're used to seeing. Okay, that's the picture that we're going to think of corresponding to the first basis, beta. And then over here to the right, we've got kind of a complicated looking picture. So the first thing you might notice is there's a pink grid in the background that simply is a recopy of the standard coordinate axes. And then there's a second set of axes, y prime and x prime. And those are the axes that go with our basis beta prime. We're going to see why that's the case as we go through the problem. Okay, so let's clear a little clutter away here. And then we can get started filling in the table. All right, so filling in the table is going to involve looking at 6 different points. And just to make this easier to talk about, I'm going to start by labeling the points. Okay, so 3, 1, let's call that P. Okay, I'm going to skip over the letter Q. You'll see why in a couple of minutes here. So R and then S, T, U, and V. Those will be the names for the 6 points that we're going to look at. Okay, and what we're interested in is filling in coordinate vectors relative to our two bases, which are at the top of the page here. All right, so let's start with the point 3, 1. All right, so we can plot it on both of our pictures to start out with. So 3, 1, that would be here. Okay, and then if we replot it over to the right, that same point is right here. Okay, and what about the question of coordinates then? Well, jumping back up to the top of the page here, let's first notice that since beta is the standard basis, the coordinates relative to the standard basis, I claim, are just going to be 3, 1, the same two numbers that we started with. Okay, but what about for beta prime? Okay, this second basis that we have up here. Okay, well, there's kind of a neat way that we can find the coordinates by looking at our picture over here to the right. Okay, so what we're going to focus on are the x prime and the y prime axis and ask ourselves, how do we get to this point P using those two coordinates? Well, we would start at the origin and notice that we need to go 1 over on the x prime axis and then 2 up on the y prime axis. So we could say that relative to the primed coordinate axes, our coordinates should be 1 and 2. 1 over and 2 up on the x prime and the y prime axis. Okay, now, are those two vectors that we found here and here really correct? Okay, I'd like to check those just to convince you that this is working. Okay, so down in the space below, let's do 2 calculations, starting with 3, 1. Okay, relative to the standard basis, if this vector, okay, is really correct, then what should be true is that 3, 1 is equal to 3 times the first basis vector in beta, which was 1, 0, plus 1 times the second basis vector. Okay, you can do that calculation and confirm that that's really correct. That's a true statement. And so what we have just confirmed is that the coordinate vector of 3, 1 relative to the standard basis really is just 3, 1. Okay, and so what we've done is to confirm, kind of going back to the top of the page, that calculation right there. Okay, now, what about relative to beta prime? Well, what we came up with is 1, 2, and if that 1, 2 is really correct, then 3, 1 should be 1 times the first basis vector in beta prime, which is sitting here, sorry for the scrolling here, plus 2 times the second basis vector in beta prime, which you can scroll up and notice is 1, 1. Okay, I'm going to leave it to you to actually add those together. 1 times 1, negative 1, plus 2 times 1, 1, and confirm that that really does give us 3, 1. There's our confirmation that the coordinate vector of 3, 1 relative to beta prime, our second basis, really is the vector 1, 2. Okay, let's see if we can complete the rest of the chart here. Okay, and just to avoid our diagram getting cluttered, I'm going to do kind of some regular erasing as we go through this. Okay, so we're ready then to look at the point R, okay, which they tell us is at negative 2, 0. So let's first plot that point. So negative 2, 0 is there. There's R. Okay, and over on our other picture, R would be sitting here. All right, and we could ask, what are the coordinate vectors of R? Well, relative to the standard basis, there's going to be no change. We'll get negative 2, 0. What about relative to beta prime? Okay, well, looking to the grid on the right, we'll find the origin. And how do we get to R on the primed axes? Well, we need to go 1 to the left on the x prime axis and 1 down on the y prime axis. So that's going to be negative 1, negative 1 on the primed axes. Okay. And we'll keep doing this until we've filled in our table. All right, so next on our list then is the point S. Now notice that in this case it's a little bit different because what they start us off with is not the point itself, but the coordinates relative to the basis beta prime. Okay, so how do we locate that point? Well, we need to go to our primed axes. So looking to the right and bottom of our picture, x prime and y prime, we need to go start at the origin and go 2 over on the x prime axis and 1 down. That's going to put us here. That appears to be the location of S. Okay, and if we replot that over here, okay, there's our S. Okay, so let's see, S is the point 3, negative 1, if we look at the picture to the left here. Okay, and its coordinates relative to the standard basis then are just going to be 3, negative 1. Oh, I'm sorry, wait a minute, back up. I read that wrong, didn't I? Okay, that is not right. So S is at 1, negative 3. I reversed those. Okay, now, let's pause for a second here, and if you feel like you're getting the idea of this, you might want to pause the video and see if you can fill in the rest of the table. Feel free to do that if you want to, and then when you come back, we'll fill it in together. Okay, welcome back. So let's see if we can fill in the rest of the chart here. Right, so we are up to T. Okay, they give us the coordinates relative to beta prime. Okay, so we need to locate that point using the x prime and the y prime axis. So we'll start at the origin, and 0, negative 2 on that axis would be over 0 on the x prime axis and then straight down 2 on the y prime axis. So that puts us here. Okay, so there's the point T, and if we replot it over here, we can see now that T, relative to the standard basis, has coordinates of, let's see, 2 to the left and 2 down, so negative 2, negative 2 it looks like. Okay, and that would also be just the ordinary point. All right, and moving on to U, let's see, this time, the 0, negative 4 that they give us are the coordinates relative to beta. Okay, so to locate that point, we'll be looking over here at our ordinary coordinate system xy. So 0, negative 4 is sitting down here. Okay, and if we replot that point over here, we've got U. Okay, so our actual point is 0, negative 4, and what's missing are the beta prime coordinates. Okay, so let's look at our primed coordinate axis. We will start at the origin and ask ourselves, how do we get to that point U? Okay, well, let's see. We need to go 2 along the x prime axis and then negative 2 along the y prime axis. So it looks like 2, negative 2 would be our coordinates. Okay, and finally, one last one to go. Okay, so this point V that we have over here, they're giving us just the ordinary standard basis coordinates, negative 2, 3. So to we're going to get the point, -2, 3, and to locate it, we will look over at our picture coordinate system to the left. So -2, 3 would be up here, it looks like. Okay, and if we replot that point over here, there's V again. Okay, now the coordinates of V relative to beta prime are going to be a little bit interesting because it's sort of between whole numbers. Okay, so if we start at the origin, we need to go over 1, 2, and it looks like a half of a coordinate. And then to get to V, we need to go up a half of a coordinate on the y prime axis. So what would those coordinates be? Well, -2.5 and 1.5 apparently. Okay, so wow, that was quite a bit of work filling in that table here. And finally, we're ready to kind of come to the point of this section. Okay, so what we would like to be able to do, as suggested by the title here, change of coordinate matrix, is to change between these two coordinate systems. In other words, notice that if you look at this table here, we've got a list of coordinates relative to beta prime, we've got a list of coordinates relative to beta, and is there a way that we could convert from one coordinate system to the other? What we're looking at, what we're looking for, is a matrix that we could multiply by, we'll call it Q, that would take us from the beta prime coordinates to the beta coordinates. That's the whole point of this section. Okay, and so in the next video, we'll kind of continue, pick up where we left off, and see if we can figure out what that matrix Q is.